Good morning, guys, gals. What's up? Today on the We'll Fix It team, we're going to be pulling an intake and replacing it on a 4.2 liter Ford 2001 model. They're pretty much the same throughout the years. The top plenum changed a little bit in the earlier years, but this one, what happened was a bypass tube rotted out. This right here had rotted out, and so we've got a good used unit here. We'll have to swap a few pieces and parts, and I'll do the video on that on the back here for the variable runner length, and I'll explain variable runner lengths and how they work, as far as like why you see that butterfly in that intake, and why you see. A quick story on that is there's actually two separate intakes in this motor, and they use these little in case anybody wants to wonder what the variable runner length servo does. I can't get it in the picture. Oh, I'm trying to do it. I need to flip the camera around, but let's flip the camera around right quick. We'll give a little rundown on this. Okay, what you have here, which I'm going to swap the better unit out. This is a servo, and it can move. This one here is missing the rod, of course. I have to swap some stuff, but it can actually change. If I can get a hold of it. Here you go. Let's see. You see how I'm moving that there? And what's happening is we'll close this runner off and divert all air to this one. And what happens is in the plastic part of the intake, when I get that off, I can show you a little better. There's two actual intakes in this top plenum. The first set of runners are really short. The next set are really long. And I'll give you a little info on what's happening here. Air has velocity. Air has mass. Air has a certain amount of mass weight to it, which means if you start moving air in a direction, it starts to have weight or mass behind it, and it can actually, once you take the force away from it, kind of like keep moving along, just like an object in motion. It's weird how a gas can have that same property. However, it's not a whole lot, but it's there. In other words, it can exceed actual atmospheric pressure, or what your atmospheric pressure would be pushing down to let the air flow to the motor as the piston goes to bottom dead center. So what you do is you maximize those aspects of a naturally aspirated engine. You'll at low RPM, you would use the long runners of the intake, because the long runners are kind of restrictive in high RPM applications. But on the when you're at low RPM to mid range, the longer runners have more air in them, and once it starts moving that more air in them, then you'll actually have mass or weight behind it, where it actually kind of charges the cylinder at low RPM, creating a little bit more airflow into that cylinder that can add a little bit more fuel and kind of give you a little more oomph, a little more torque. And then when the engine comes up to a certain RPM and a certain amount of cubic feet per minute of air being moved by the engine as the pistons accelerate in their speed and more air is being drawn into the engine, if you shorten the runners up a little bit, then you'll get less restriction, more airflow, and your air already has mass behind it because it's got more speed behind it, which is the whole dynamics behind a dual plane and single plane intake and the drivability issues on a gasoline carbureted engine. That's another video. So basically today, though, we're fixing a water leak. Now, I guess a good explanation on variable runner length control and how that works on a gasoline engine. And you're going to see that a lot with just a lot of new engines. You'll see where they have the intake is made out of a injected molded plastic. They do that because they can easily cast a dual sectioned intake. I guess you'll call it that. But anyways, let's get started. First thing we're going to do is, let me flip the camera. I'll put my light up here so we can see better, but I've got to just get the front down, got to get this off. I'm going to get these hoses out of the way. There is a few vacuum hoses and solenoids I'll be taking off. Basic tools for the job: 10, 13, 11 every now and again, maybe but 7mm to get these. This little there's a DPFE sensor right here. Well, nope, this is new enough where it doesn't have that. It's right there. Some of them had them bolted on the side over here. You move that, and I'll explain that. EGR systems, I know a lot about that, so that'd be a video we do as well. And I'll even, through this video, give you a little secret as why these 4.2s, 3.9s would have a cylinder 1 misfire on the first 1,000 RPMs, and then an insufficient EGR code, and then a weird misfire after the engine warms up. And it has to do with these right here. And what happens to the EGR ports as they stop up and divert all the EGR to one cylinder. And when you crank it up, you have this check system that checks the whole thing real quick, shoots a lot of EGR off the very start, gives you that first 1,000 RPM code start up, misfire cylinder 1, and then you'll have an EGR insufficient flow because the rest of the cylinders aren't dispersing EGR evenly because it's got to travel this whole length coming off that EGR valve at the front to actually they all stop up little by little by little, and then just all of it squirts out right here. So one cylinder gets it all, and the rest get none. The oxygen sensors on this side see no EGR going on, don't see the temperature changes, so they give the code. Bam, simple as that. So you pull the plenum, you'll pull the valve, you'll take a wire, you'll clean all that out, you'll blow that stuff out, you fixed your code. You're good to go. Anyways, all right, let's get started. All right, so here we are getting the upper plenum off. We flip the camera around, and I can show you a little bit about the dual runner links that I was talking about earlier with that butterfly in there, part of it. Okay, so here we are, and you can see this is from right here to right here is a section of runner, and for the same cylinder they'll use here to here and this little short part, and they'll split it up amongst these holes right there. So that uses different lengths runners. So you can notice here that they're using the whole intake right here. That actually just, so they're using the whole plenum right there. Once you get into RPMs, this was just for low because it's a little small focused runner to try to charge the air as it enters into the cylinder. And then that right there switches it over to a higher RPM full plenum mode where you're just drawing air from the general area, which is a more open and unrestricted area. So yeah, that's part of the variable runner length control, and that's what you're doing when you're switching that butterfly inside the intake. Okay, and this is a little bit, now to get this off, I had to just take a few vacuum hoses, and there's several bolts behind here, 10mm deep well quarter drive and a little ratchet. Got that real easily from this side right here. And each one of these holes, there's the bolts that mount this part. However, there are a couple of other little things I've got to remove. The water lines here, I've already removed the vacuum hoses off of that EGR actuator solenoid. And so we're getting there to it. We'll get to this is what they call the mid plenum, by the way, in case anybody's asking. Then there's grommets. You want to get the gasket set that has these grommets. When I pull these bolts out, and I'll explain that here in a little bit. Give me a second here, we'll be further into it. Okay, we're back. And here we are now. Let me flip the camera around and I'll show you about these bolts. See that green thing there? That's called a grommet. And I'm sure we know all this, but this thing has way more than just looks like a piece of rubber. It has a very, very important job, this green thing does. And these look kind of new, but I'm still going to put new ones back. They do tend to swell up, and when you try to put them back in there, they can catch the sides of the hole and tear this right here. But you see this bolt has a step right there. When you tighten this bolt down and it stops on that little pedestal in the aluminum of the intake. After that, it's this green thing here that allows the amount of pressure to be applied to the intake to push down to seal it on your intake runner holes. And there's little O-rings, and these things here can give a lot of trouble over time. These have been replaced, but we're going to put new ones back. I don't really want to use old stuff unless it's my own. It's in the yard. We're just trying to make it run. But there has to be enough pressure pushing down on these to seal these off. And when you tighten this bolt down, it stops, and it relies on that rubber grommet to do that. So if you try to reuse these grommets, you may be okay if they're new ones and you're working on your own stuff and it's not going to come back on you and make your business look terrible. But for me, I need to replace these with new ones because I want this thing to be to run all together. I want it to last. This thing, when I put this together and the intake's good with the right amount of antifreeze in it so nothing rusts out the system, we'll get years and years and years out of this. We're going to get a lot more time out of it. And these O-rings, when they start to go bad, or the grommets that hold the intake down, you'll start drawing vacuum around each one of these individual runners, and that causes a misfire at idle as well, or system bank lean condition, where you have like this code that says system bank lean, and it'll if it's dependent upon what O-rings are leaking, bank 1 or bank 2, if not all. Lopey idle on a cold start is another sign of a vacuum leak or intake runner length problems, where you have a lopey idle. It kind of sounds like a race car for a second, then smooths out. Poor fuel mileage. So that's just something to think about there. So let's go ahead and get a little further into it, and we're going to be going all the way down to get this thing here off. So I've got to remove the ejector rail, some more hoses. The EGR valve, will just unbolt it and leave it tied to this piece of metal tube because that's a very delicate piece there. I remove those if I have to, but it's usually a sticky situation. So we're going to take just enough off to change this intake. And there you can see our variable runner length control servo. Servo being the fact that it uses a step motor and position acquisition to achieve a certain amount of runner control length. Just like on a remote controlled car, they have servos that control front tires, you know, left and right on your front tires, and possibly different things. All right, I'm gonna get off subject, but okay, here we go. Alrighty, everybody, so here we are now. We've got the intake off. Let's see if I can get a shot of that. I was going, this is the replacement, which is a used unit. I got it at a salvage yard. This is the one that came off of it. Let's flip the camera around. All right, so here we are. The tube, there's a tube. I've got this thing strategically placed on the bench because when you get it, if you have a replacement one of these and it's a used unit, you need to be careful with that tube. That tube right here. That's what rotted and caused a water leak. So when I put this thing upside down, I don't want to leave it on this tube because it'd be like, boop, and I'd be right back where I started. I've got to do a few little swips and swaps here. I'm going to have to swap out some. This here is missing some of the servo stuff, but that's okay. I've got some of these little bushings. Dorman makes them. They're not they're not my favorite, so I'm going to try to save the original ones. But here are some right here. We'll see how they hold up. But that right there is to control that runner length. I ended up pulling the EGR valve off because it was just kind of cumbersome and in the way. And I pulled the thermostat housing off to get it up through the motor. And we'll take a quick look at the inside of the engine here. These little 4.2 motors, I will not say they're bad engines, but some of them had a issue with cylinder head gasket problems. This one may not be the case because it's past its time for it to do that. Either they did or they didn't do this, where all of a sudden they would hydrolock a little bit, bend the connecting rod, and then you would have to take the motor. I mean, they were just bad. I would take these out when that would happen and put a 3.9 liter Mustang engine, which is the identical design. I bet you if I got my boroscope out and my thingy and measured the displacement, it's probably, this is a 3.9, but they say 4.2. I don't know. I won't say that, but the 3.9 was a good motor. They did not have the head problems that these gave. But this one here it's done pretty good. These things are built well. They were made in Windsor, Illinois, which makes them a 4.2 liter Windsor, ironically enough. And I really think they have a 302 bell housing. I think you could probably, I haven't tried this, so don't hold me to the fire on that, but daggone it, if I look at it real close, it almost looks like an old school 302 bell housing. The starter even bolts to the transmission via some bolts. It's a little different bolt pattern. It's a 3-bolt pattern, I think. Don't hold me to fire on that either. I can't remember everything, but roller lifters, a really cool balance shaft to kind of smooth the V motor's never balanced out. An inline motor is a well-balanced engine, and an opposed engine is a very balanced engine. All V motors are going to run out of balance. You have to work to get them to do right, just because of the geometry of the rotating assembly creates vibration. If you oppose the cylinders, you're good. If you inline the cylinders, usually you're pretty good as well. But they fit in things really easily, so that's kind of how that works. What else here? It looks like we're going to be on go here. I'm changing it because of that tube. So what I'm going to do now is I'm going to pull off those gaskets. But what I want to stress again in this procedure is I'm going to be using this right here, and it's actually that disc is a little bit too good for me. I've got one that's a little more worn out, and I will use it just to kind of clean off the remnants of the old gasket and some of the old Duke that's right there. And I will pull this housing off and clean this up. I'll clean that off with the EGR valve gasket. Here we are at this point where I was talking about on one of the videos where you're using this tool and this thing goes, it's going to be spinning. It's going to be cleaning and taking off the gasket. But aluminum's pretty good stuff, but it is somewhat susceptible to abrasive stuff. So when I'm doing this, I want to transition this thing like that. We know how we love transition. We'll transition to a completely flat here. When I go from here, I will not use any pressure at all. I'll actually pick up, transition down here, and then come up. That way I'm using a flat angle. You don't want to round these corners off. That's a big thing. These things got to have those sharp angled corners to and the gasket would go right here. So yeah, be careful with that always. And if you do that, you're going to be just fine. It's amazing that people say aluminum doesn't rust, but water has minerals in it that can corrode, and the aluminum is cast. So if it can get into the porosity of the aluminum, then it will start to break away at it, just because of the fact that it just causes a form of corrosion. Rust is just a different form of corrosion. We're used to seeing it as brown. Alrighty, well, let's get this all cleaned up. We're gonna 8mm bolts is what held all these in. If you're working on this and this is a do-it-yourself job, you've got a little hidden bolt on the back side. And if you ever have your replacement intake, you can see that. And that one's probably the hardest one to get to. I mean, obviously, but it's not as bad as you think. I just used an extension, a 6-inch extension, and an 8mm quarter drive socket, and broke it loose. And when we tighten this down, I'll be going from the very center bolts. I'll actually go center bolts, not full torque. Then I'll go outside bolts, and then I'll go center bolts full torque, and then outside bolts full torque. And I'll do it in a circular motion, moving out. That will be how I will do that. And I've had great success with that. So yeah, all right. Hello everybody. Okay, quick gasket cleaning tip that I learned from an old schooler from years ago that, man, I loved it. This applies to those gaskets that are hard. They're really thin paper gaskets, and they'll get completely cooked to the surface of something, and you try to scrape it off with a razor blade, and you just end up fighting the thing, and you're scraping and scraping and scraping. And if you use the little cleaning tool that I have here, that works, but you sit there and have to clean on it because it's so darn hard. I don't know if anybody's ran into those gaskets before, if you're into do-it-yourself stuff, and this right here. A ball peen hammer will do the same thing, but I use this because I really like this edge. I made this probably back when I was like 19 or 20 years old. I was a mechanic at a golf course, and I had a special use for this tool. And the reason why I welded that offset is for a very reason. It was working on a piece of fairway equipment for putting in a part on one of the reel mowers. And this thing was what I even kind of coined it my little pecker, because everybody picked on me because they had fancy tools and all this. But I ended up using this thing later on to knock races out. I could put it in and anyways. So this tool has been very awesome. Let me flip the camera around and show you what I'm going to do. And this works on like timing cover gaskets, other things that actually are really hard to sit there and kind of like, you sit there and clean. Stuff's going everywhere. And yeah, so like, okay, here, let me flip it around. Okay, here we are. So I've got a full video coming out of this, and this will be part of it. But you'll just take this gasket and just kind of tap around on it. And it will just save your life. We'll just keep going around. I'm not hitting it hard enough to go completely through the gasket. I just want to kind of just mangle the surface a little bit. I'm doing this one-handed and trying to look through the phone. It's not easy. I could have took my little tool and went on it for a while, and that dust would have went everywhere. Then I would have sat there and pitted a little bit. That's fine. There we have it. Quick gasket cleaning tips. Use that on those really hard, those foreign engines were the worst for those timing cover gaskets, and those hardened up gaskets that are real thin paper. So yeah, thank you for tuning in to We'll Fix It Team. Okay guys, so we're getting ready to put the gaskets in place. What I'm going to use here is something I really love. I love my wife, but I love this stuff too. It's called the Right Stuff, and it's made by, let me see here, flip the camera around here. Permatex makes this stuff called the Right Stuff, and it's really, really awesome. It is absolutely, I stick these little doodads to the workbench without even cleaning it, just to show people. It's like, you have to, look, it didn't even pull off there, it broke in half. I mean, look at that. I finally got to pull, and that's not even after cleaning it. Usually what I do before I do a gasket, I'll take this brake cleaner and I'll spray it on my rag. I'm using one hand, and I'll use that, and I'll go around all my surfaces to get any and all oily residue off, because you've got to have a clean mating surface. Oily residue is a pathway for coolant and anything to get by a rubber gasket, because it's not touching the metal surface completely. So and so I always go around everything. I clean everything off really well with brake cleaner. Now, if it's a really nasty, dirty surface, I take a little water bottle like this right here, and I just poke a hole in the lid of it, and I'll use just some good old gas, because brake cleaner is so expensive. And I'll do the same thing. I'll knock the brunt off with that. But yeah, and so you'll notice too, while I was cleaning this, I laid some rags down just to catch any debris, so we won't get it all on our roller cam lifters. And I took a screwdriver and a grease rag like this right here. I just kind of threaded it on the end and went into each one of these holes right here where your injectors go, and cleaned all the debris and dirt around that, because we're going to be reinstalling those injectors with new O-rings, and so we don't want any dirt getting between there and causing any vacuum leaks, because you can develop a vacuum leak there and create a problem all in itself. But all right, so let's go ahead and get our gaskets on, and then I'm going to set what I'm going to do too is, there in each corner right here, when I put the strips that go on, usually on Chevrolet small blocks where they used to have the cork that would go across here and it would blow out, even the Fords, the Windsors and 302s, I would just build up a huge bead of that right stuff and let it layer down on top of that, and let it ooze over each corner, and I would have absolutely awesome success with that. But that won't be the case, because the design of these gaskets or seals are actually really, really good. And so the only thing I'm going to be doing is applying a decent amount of gasket sealer in these corners, front and rear. I'm going to go back here and do the same thing. I'm going to apply gasket sealer in there, and that'll take up any imperfection where the gasket can't meet these corners. And I'll go ahead and put a little film around each one of these water jackets, just to let the gasket squeeze out around that. Squeeze the mess. That just helps to kind of just keep stuff there. There's a little bit of imperfection just from the aluminum and water combination that I was talking about, how it can get in there and kind of like, corrode the aluminum away. That's what happened right here as well. You may have seen in one of my other videos where I said a little bit of whatever, corrosion, or pitted out, and that's right here. And I will just, the gasket that I'm going to be using will take up for that. I put a little bit of stuff on it called High Tack. It's really awesome stuff. It's got a little brush, and that's what I'll use to do that. So we'll get everything on. We're getting there. Yep. Okay, so here's some of the layout of the gasket. I'm gonna flip around. You'll look right here, you'll see the gasket says front. And so that helps you kind of take some of the guesswork out, but it's going to go this way. And as you can see, I've already got some of the layouts there. You can see what I did around the ports. Just a real thin layer. I always do that just to be sure. It won't hurt anything, and that helps to just kind of keep stuff in its place. And like I say, I like those strip gaskets like that. Yep. So we'll go ahead and get these in place, which I'll need both hands for. Then we'll set the intake on and we'll tighten her down. All right, here we go. Thank you. We all got both gaskets in, and you want to make sure that there's little holes that stick off that line these gaskets up in the corner right here. You want to make sure those holes are cleaned out. You want to make sure you're pressed in really well. And as you can see, I reapplied a little bit more of the gasket material making stuff, that polymer, to ensure end seals, or corner seals, that's what we're looking for. And yeah, and here we are. So now we'll get the intake set on. But that's what you want. That's what you want this to look like. And of course, I did apply just before. Get the head of myself here. As you can see, I did the same thing to the intake, just around some of your common ports for coolant, where there'll be water. And so, yeah, we'll see how this rolls out. What's up, everybody? Quick thermostat tip right quick. I don't know if you guys done this yourself or not, and notice, you see how that thing has a little thing in it? You guys know what that's for? Well, anyway, I'll go ahead and tell you. You can't answer me. Let me flip the camera around and I'll give you an idea here. Alrighty, so that little thing that you're looking at right there is a bleeder. And what it's designed to do is, it's designed to allow any air pocket that gets trapped in the system to kind of like bleed itself out. And it's a handy thing because you can get air pockets in systems if without even doing any work to the vehicle. You could have a small coolant leak, and you might notice it low, and you'll fill that tank back up, and you'll ride on. It might be just a real minor leak, and what will happen is, if it gets down below the thermostat level, it can seal off and not allow water to reach it, so the thermostat doesn't open because there's not enough water all the way to the top of the block. and it gets a lot hotter before it opens up. So this will actually let a certain amount of water. If you actually run this thing, you'll notice a little bit of water might come through here, but definitely lets the air bubbles out. So the trick to this thermostat is to always install it so that that little device right there is uphill. Don't ever install it sideways, upside down, you know, wherever it's at in this position, whether it's in the center of this motor right here, like that, or it's off to the side, anywhere. You always make sure it's straight up like that right there, and that way this thing will be properly installed. Now, I'm gonna do a little trick here because that's a pain in the butt to get in there, this motor. And I'm gonna use a little bit of weather stripping adhesive. This is no joke, guys. It's gonna be my saving grace here. But I've got to get this down in that hole and make sure that the thermostat doesn't slip out of place. So I'll use this 3M weather stripping adhesive, and I'll apply some of it below this valve right here. We don't want to put it anywhere near that valve because we don't want to stop the flow of that off. So on the, it'll go in. You always want the spring or the thermostatic part right here is in the center of this. So coolant has to get on this to heat this up to allow the stuff inside of it to open up this valve. So for good measure, you always install your thermostat towards the water flow. So if the water's flowing, if you're at the, you know, to the direction, this always goes into the flow of the water or into the motor itself. There are other ways, other thermostats go in some weird external housings. I'll cover that in other videos, but for basic, you know, for working on stuff like this, 302, 350s, and a lot of other, just always make sure that this spring is in towards the water, not towards the radiator. Rule of thumb. But I'll kind of like adhesive this thing right here to this piece here, so I can just use one hand, set it in there, and then hold it and put my bolts in. And I'll use that weather stripping adhesive to do it. But mind you, I won't go anywhere close to that little bleeder with it. Okay. So here we are. I'm getting ready to put the upper plenum on it, or sorry, excuse me, the mid plenum. Getting ready to install mid plenum. We've got all of our new grommets installed to go on the bolts that hold it down because we want that pressure. Let me flip the camera. What we're looking at here are the new plenum seals, and you don't want to just slam these in here. You want to make sure that they're all nice and looking up. You can put these things in and they can be kind of pushed over a little bit and overlooked, and that's not good. That will leak vacuum. So we want to make sure that all the O-ring seals are properly, you know, looking at me really nice, seeing they're straight up. This one here is over just a little bit. Let's center it. And of course, my greasy fingers, I will wipe these off. But yeah, we want everything looking straight up. So when we put this down, they don't lay over. And remember now, these grommets on these bolts are a big deal. They push this intake down because it's going to stop on these steps right here. So if you use the old grommets, you may not have the best outcome. I always recommend getting the whole gasket set and doing that. All right, well, let's get her on there. All righty. Upper plenum is on now, or mid plenum. Mid plenum is on. Upper plenum is the part that goes on top of that. So that's the lower that I changed. The mid, and that's okay. We'll wipe that out. That's no big deal. All motors look like that. All these 4.2s do. But yeah, so that's where we're at. Now I've got to hook up 2 water lines once I get that top part on. One goes there and one goes up underneath there, but I can get to that. We're getting in the short stretch of this thing, folks. Sure enough. Yeah. Well, all right, everybody, we've got it running. It's and everything seems to be on go. Let's flip the camera around and take a look. There it is. I still got to put the little cover around this throttle. What I'm doing is running the motor with the radiator cap off for a little bit, because even though that little thing I showed you in the thermostat helps to purge the air, there's still the remnants of air in the system. So we'll let it run a little bit, open the thermostat up, and then I'll be comfortable knowing that I've got all the air out of the system. But it's running really good. It fired right up, and all I have to do now is just make sure I don't have any leaks. So we'll let it run. I'll drive it around some, we'll park it, and it'll be ready for the pickup tomorrow. So thank y'all so much. I really do appreciate it. Can't thank you enough for tuning in to this Will Dixon team. Together we can fix America, or at least try. All right, guys. Thank you very much again. I'm going to get out of here, and I'm just so grateful for all you guys tuning in. More content to come. Lots of fun videos. I'm out.